For nearly a century, the Burnham Foundry in Zanesville, Ohio, has been turning out quality castings for the heating industry. Today, with more than 3.5 acres of production capacity under roof, it continues to be a leader in casting both hydronic components and items for a variety of other industries. The basic materials used in sand casting date to the beginning of history, but employing them in a large-scale, precision manufacturing process requires cutting-edge tools and techniques. Burnham Foundry melds the traditional founder's craft with advanced technology like automated molding, CNC machining, and extensive testing and quality control. Burnham Foundry's worldwide reputation for quality begins at the design phase. When casting, the size, shape, and thickness of product components can be critical determinants of performance. Burnham Foundry helps optimize the design of the products it produces by using advanced 3D modeling and a century's worth of casting experience. While computerization has greatly accelerated this process, it is simply an aid to final judgments based on the experience of the foundry craftsman. Other key components in Burnham Foundry's success are the materials used: sand and scrap metal. It sounds pretty basic, but the sand must be specially measured and mixed and constantly tested to maintain the precise physical properties Burnham Foundry quality demands. Burnham Foundry recycles thousands of tons of scrap metal each year. It consists of a mix of scrap plate and structural steel, automotive parts, and cold-pressed briquettes of machining waste, along with remelt of foundry production. Scrap components are certified as to content by recycling suppliers, and each is weighed on a large-capacity pan scale to ensure uniform composition of the molten metal produced by the furnace. With a proper mix of scrap metal and enough coke to recharge the hungry furnace, another 1,800-pound charge is subjected to its 3,500-degree fiery fate. Burnham Foundry's modern furnace has the capacity to melt up to 23 tons per hour. As the metal liquefies and the various components combine, it filters through the bed of glowing coke, picking up additional carbon. Finally, it reaches the required state to be poured. Burnham Foundry produces two types of cast iron. The crystalline structure of the graphite in gray iron makes it more suitable for heat transfer applications, such as boiler components. Ductile iron is created with the addition of magnesium at the time of the pour and is used for castings which require high tensile strength and flexibility. To ensure that precision carries through the process, measurements of the molten material are taken right at the furnace with every pour, and follow-up laboratory analysis is done on every batch of castings. Another critical process that must precede the making of molds and the pouring of metal is the making of molding cores. Also made from sand, these act to displace the molten metal from the hollow parts of the finished product. Burnham Foundry uses both warm and cold box core production processes. The difference lies in how the resins that bind the sand to the desired shape are catalyzed. Although core production is automated, final inspection and preparation demands individual attention. Once a slow, labor-intensive task, automation has dramatically changed the way mold making is done. Burnham Foundry's D-somatic line is capable of making 250 molds and pouring 20 tons of iron per hour. In an operation much like injection molding of plastic, a special green sand mixture is combined with the core under pressure to create the finished sand mold. Finished cores are then loaded in between the molds. Even the filling of the molds with molten iron has been integrated into the process, as has a programmed cooling cycle. and the separation of castings from the molds and cores. It's a 200-foot journey and just 1 hour from core to completed casting. Larger castings are produced on Burnham Foundry's air-set line. Here, 1/2 of a mold is formed as sand, carefully mixed with a resin and catalyst binder, which is poured into a large metal pattern. Extreme care must be taken to ensure that no spaces or air pockets are produced in this process. Then, PLC-controlled equipment gently rotates the top half of the mold so it can be precisely mated with the bottom half of the mold, which contains the cores. With a steady hand, molten metal is poured into the molds. An entire ladle is required to fill 2 of these large molds. After a precise cooling cycle, a shaking table separates molds and cores from the finished casting. Nearly all of the sand is recovered for reuse. All castings, large or small, are thoroughly cleaned, and if required, they are ground to rough dimension before final machining. Every hydronic component is pressure tested before it leaves the plant, and each batch of castings is given a precise dimensional inspection to ensure that it meets Burnham Foundry's rigid quality control standards. Final inspection and shipping, the last step in Burnham Foundry's production cycle in Zanesville, becomes the first step in our Lancaster plant's manufacturing process. Today, Burnham is producing the world's most complete and advanced line of boilers, and the heart of Burnham products is cast in the fires of the Burnham Foundry. Zanesville, Ohio, USA. At Burnham, we're on the move with quality products that are made in America.